morning, and welcome to IBM's Thomas J. Watson Research Center in Westchester, New York. We're going on a tour of the User Interface Institute today. We'll try to give you a sense of what we work on and what we care about. Fundamentally, we're working to make computer systems interactively richer and easier to use. We're also working on programming technologies that promise to make application programs easier to build and easier to change. You'll be hearing from a number of folks today, so why don't we get started? Shall we go to the lab? Usability engineering, a set of techniques including setting measurable usability objectives, doing early prototyping, and most critically, involving end users throughout design and development. We found this set of techniques works when applied with creativity and commitment. We've also found in refining these techniques that it's very helpful to work in close partnership with IBM development.
IBM development makes a diverse set of products. Making these products work in a consistent way for end users is hard. We're applying usability engineering to help develop IBM's next generation of graphical user interface standards aimed at solving this problem. These standards are called Common User Access, or CUA. The development of new CUA standards is an ambitious partnership with several development labs and IBM Research. These labs include Santa Teresa on the West Coast, Dallas and Austin, Rochester, Minnesota, and Cary, North Carolina, among others. Usability engineering works, but it's also expensive to do, and we've got research underway aimed at making it more cost-effective.
We're conducting iterative usability testing to refine the CUA architecture. We collect quantitative and qualitative information and provide that information to the architects. We also bring in users and have them help us assess competitive systems. We're comparing empirical and analytic walkthrough methods to address theoretical and cost-benefit issues regarding human factors and user-centered design. A side benefit of this has been the development of a human factors technique for content analysis of usability session log data using a hypertext idea processor. During usability testing, we collect a wide variety of data, including video. We're developing logging tools to record and analyze these data in an integrated way.
Sometimes when we're doing usability testing, we're working with a prototype that's too new and doesn't have a help system yet. In a case like that, we found it useful to have a human tutor stand in for the help system.
How do I change the colors on the screen here?
You can choose a color scheme. Pull down the settings menu.
Settings, there.
Select Control Panel.
All right.
Double-click on the color icon. And now you can choose a scheme.
Tutoring studies are a very useful way to identify the requirements for a help system. They can also point out other problems with the user interface that need to be fixed.
One of the problems that we're interested in is the problems that developers face when they go to build an interface that conforms to a particular user interface style. What they have are a whole raft of components and then a series of guidelines that apply to those components and then trade-offs among those guidelines. And what they have to do is they have to apply those different considerations to every screen that they build and to every way that a user might want to interact with those screens. So we're looking how we can support developers. We've looked at the role of examples in conjunction with explicit guidelines, and now what we're trying to do is to develop a tool in which developers can interactively see what the relationship is between the examples and the guidelines.
We work with design teams early in the design process, often before ideas have been completely formed or the prototypes are available. Now, we use the four walls of a design room to hold representations of information important for system design, project goals, development tools, and representations of designs in progress. Now, we find that by making this information explicit at meetings, it becomes part of a shared vision, and this is key for team design.
We frequently collaborate over a video link between California and New York. In our work with over a dozen design projects, we have found it very important to develop a shared vision among the members of the team who come from a variety of backgrounds. By surrounding the team with appropriate representations, we emphasize that design is really a search through a space of designs to find one that really supports users in their work.
Usability engineering implies change. Taking it seriously means when you start a project, you really don't know how it's going to end. If you're going to build systems under these sorts of conditions, you need tools that can track the kind of change you really will face. In our own work, we found Smalltalk to be an excellent vehicle for keeping up with change. In particular, we found it to be great for prototyping user interfaces and are using it now to prototype future versions of CUA. CUA is moving towards an environment where nearly everything can be directly and predictably manipulated. To take one small example, text can be moved or copied by simply being dragged and dropped. With Smalltalk, we are currently exploring the subtleties of selection and direct manipulation.
Smalltalk programming is different from programming in traditional environments. One does not create standalone programs. Instead, one continually modifies a running environment, making changes as one goes along. The change manager captures this behavior and saves it in groups, groups which align with the conceptual groupings of the programmer. These groups can be shared with others.
Smalltalk already provides a nice environment and includes some facilities for the special needs of object-oriented programmers. However, there is not enough support for dealing with objects after they've been instantiated. Portia is an environment built on Smalltalk. It encourages programmers to deal with objects in new ways. What it does is allow programmers to find the objects that make up running applications, move those objects to various software tools, and use those tools to understand, manipulate, and experiment with the objects. Object-oriented programmers work with objects in their minds. They consider the behaviors, the connections, and the states of those objects. The environment should make those conceptualizations explicit.
Diverse, independent teams of experts each do their work in their domain of expertise. We can take the best product of their work and make it reusable by encapsulating it into objects. Combining different objects enables us to make new and powerful applications. This complex graphics application reuses RPC object to send messages over local area network.
Not too long ago, applications with graphical user interfaces were considered somewhat exotic. They were also considered somewhat hard to build. If you look at the field now, you can say similar things about multimedia. Applications incorporating multimedia, in particular applications with motion video, are still somewhat exotic and they are hard to build. We're working now on tools to make the building of these applications considerably easier.
Recent advances in digital technology let us put television pictures on a computer screen. This has created a new area called multimedia, and we're learning about multimedia by doing it. We're creating tools that help the user build interactive multimedia applications. We're using the tools ourselves to learn about multimedia, and we're observing the users of the tools and of the applications so we can find out what multimedia is all about.
InBuilder is a tool for creating interactive multimedia applications. These applications can include audio, video, text, graphics, and animation. Creating one of these applications, it can be a complex task. InBuilder attempts to simplify this by providing different views of the objects that make up the application. The scene list view allows you to specify how navigation will occur through the application. The preview window allows you to lay out the media objects within a scene. The timeline allows you to specify their time relationships. And finally, the element list is there in support of the other views.
A graphical user interface is important for a user to solve such problems such as time, because time is a difficult concept for the user to really understand. And by putting it in graphical terms, they have much more control over it. When designing applications, graphics are especially important because they give the look and feel of how the application is going to run. And it is the invitation for the user to come use this particular application. Currently, our authoring tool is just that, an authoring tool. But in the future, there's no reason why it can't also be a graphical sketching tool, so that the designer can be able to think graphically and temporally at the same time.
With our multimedia tools, we built this application. John Cock, a retrospective by friends, for which we were awarded the 1990 Mark of Excellence Award by the International Interactive Communications Society. Now we're taking these same tools and sharing them with IBM's multimedia organization in Atlanta. What we're finding there is how learnable they are by people with a variety of different backgrounds.
If you're going to draw an audience into a multimedia presentation, you have to have high production value. For both the John Cock and for the electronic magazine, what we've done is we've done our own in-house production. So we do our own location shooting, we do music production, we do graphic design in-house, and we do our own editing at our own edit suite.
We're building our own computer-based editing system in order to construct an integrated multimedia development tool which will include editing, authoring, and production. We want to be able to edit and author from our offices, so the system will be accessible from a local area network, as will the routing switcher, which connects the central audio and video equipment to our offices.
The field has done a good job in creating interesting, exciting user interface technologies over time. It's done somewhat less well, however, in creating an understanding of those technologies and building, if you will, a science base. In one of our projects, we're trying to build a framework within which such a science base can be built. Our starting point is the observation that systems generally embody claims, implicit claims, about users and the tasks they're trying to accomplish.
The ViewMatcher tool allows users to learn about Smalltalk programming by analyzing a running application. The user can pose and investigate questions about the application while using it. The design of the system embodies the theory of how people learn. For example, one of the claims it makes is that people try to learn by exploring in the context of real tasks. If the claims made by the design of the system are true, the system will be both useful and usable.
Realistically complex systems embody many such implicit claims. We want to bring out these implicit claims so that designers can better appreciate them and work with them. We call this claims analysis. We represent a system with a set of user interaction scenarios. Critical scenarios, like error recovery episodes, and also typical scenarios. For example, in the ViewMatcher, the scenario in which the user wonders how some feature of an interactive application works is a typical scenario. We use such scenarios to assess and to reason about the consequences the ViewMatcher has for its users.
But once made explicit, claims can be evaluated against real usability data, and we can begin to see how the claims hold up in the face of real users. And since claims are tied to the features of specific systems, they're in a form that's very useful to the designers of those systems, because essentially designers have to choose among different options for those features. Right now we're using claims to guide the empirical evaluation of a number of different tutorials for Smalltalk programming in a kind of case study to see how the claims framework might contribute to the process of theory building.
How can would-be analysts be helped to discover the most important psychological design characteristics of a system? Well, empirical data like critical incidents are a big help, but they make it hard to ensure adequate coverage. Perhaps explicit, limited cognitive models can help. Models that describe tasks and concepts in the way that they're performed and understood by users. For example, we've been analyzing calendar systems in terms of an explicit model of the way people remember appointments.
New systems often evolve from existing systems. We're experimenting with ways for managing the evolution process. We start by trying to understand the rationale of the existing system. Then, we reason about that rationale, understanding its pros and cons in different user interaction scenarios, to try to imagine new scenarios and new systems.
Imagining scenarios means making a lot of guesses about the behavior of users. We're studying the way designers make those guesses. We're particularly interested in the way situations and systems in the background of designers can bias their imagination.
We're also experimenting with the role of scenarios in reasoning about and building a systems implementation. For object-oriented design, for example, you might take a scenario like scheduling lunch with Bob and break it down into the objects involved, their responsibilities, and their communication lines. We're hoping that if we can get designers to use scenarios to organize their implementation, they might be able to maintain a focus on the user throughout development.
Much of our work starts with technology, shaping it, refining it, and moving it into the world. But what does it take to solve a problem in the world? One approach is to start with the problem itself, letting it shape the technological solution. When application design starts with the raw stuff of the real world, understanding the situation is critical.
Our theoretical work on claims analysis and scenario-based design is being extended by applying it to a real-world situation. We're taking the analytical tools we've developed in the lab and using them to understand this sensitive situation in all its complexity and to guide the design of an application that will make a difference.
In most situations, computers are used as problem-solving tools. But for some applications, like word processing or electronic mail, it also gets used as a vehicle for people to express their feelings. And in some cases, we believe the computer has a unique role to play in the expression of feelings. This affective component of human-computer interaction is one of the things that we're hoping to explore in the home healthcare project.
You've seen some of what we do in 4 major areas: usability engineering, object-oriented programming, multimedia user interfaces and applications, and user interface theory and design. We've made quite a bit of progress over the last few years. Many papers have been published, prototypes have been built and refined. But the ideas we work with aren't for our own consumption. We're trying to increase the effectiveness and pleasure of people's work and play. The world out there, the one outside this lab, is what all of us are trying to improve.